This is part 2 of my lecture series on vectors. This time, I'll be discussing scalar product vectors, also known as the dot product of two vectors. So, stick around, watch, and learn. The first concept that I'll be discussing is all about unit vectors. So what is a unit vector? A unit vector is a vector that has a magnitude of 1 with no units. Its only purpose is to describe a direction in space. Unit vectors such as vector I, vector j, point in the directions of the positive x and the positive y axis. Each has a magnitude of 1. As an example, supposing vector A, as shown in this diagram, we can express its x and y components in terms of the unit vectors I and j. So we can express vector A as the sum of its x and y components. That is, vector A is equal to axi plus ayj. Using unit vectors, the vector sum capital R of two vectors, vector A and vector B, can be expressed in terms of the unit vectors ij, k. Supposing vector A is equal to axi plus ayj plus azk, while vector B is expressed as bxi plus byj plus bzk. As shown in these three-dimensional coordinates, all right, in addition to the unit vectors I and j, where the vector unit I is directed towards the positive x-axis, while the unit vector j is towards the positive y-axis, we include, okay, the third unit vector k, and that is directed towards the positive z-axis. So, how is vector r, which is the sum of vector A and vector B, expressed in terms of these unit vectors? All right. So, we simply add, all right, the three, components, x, y, and z components of each vector, all right, axi plus ayj plus azk plus the x, y, and z components for vector B, bxi plus byj plus bzk. And then we can also combine the components, all right, that are directed, for example, towards the x-axis. So we have ax plus bx, quantity, vector unit I, all right? And for the vector unit j, the two y components a sub y plus b sub y are added, and of course for the z components az plus bz, okay, to be multiplied by unit vector k. So this is the expanded form of the resultant vector capital R. Okay, when we say x, y, and z components of the vector R, this is how it can be written: rxi plus ryj plus rzk. So for our first example, question number 1, find the x and the y components of a force vector, vector A, if vector A is equal to 5.0 times vector B, where vector B is expressed as 4.0i minus 6.0j, okay, expressed in Newton. So our solution, we just follow what is written in the question, that vector A is equal to 5.0 multiplied by vector B. That is 5.0 to be multiplied, all right, by 4.0i minus 6.0j, okay, and this is expressed in Newton, of course. Simplifying, we say that vector A is equal to quantity 20 with two significant digits, 20i minus 30j, all right, expressed in the force unit Newton. All right, so it's very clear from our answer here that the x component of vector A sub x is equal to 20 Newton with two significant digits, while its y component A sub y is equal to negative 30 with two significant digits Newton. So vector A can be shown in this sketch or diagram. All right, so this is vector A, its x component A sub x and A sub y are as shown. Reads, find the angle between these two vectors. Vector A equals negative 2.00 I plus 6.00 j, and vector B equals 2.00 I minus 3.00 j. So the solution in determining the angle between two vectors is applying the concept of scalar product. Scalar product is also commonly known as the dot product, whose formula for finding the angle theta, it is equal to arc cosine, all right, of the ratio of the dot product of the two vectors, vector A times vector B. So the numerator is called the scalar product of the two vectors, and this is denoted by a dot symbol. All right, a dot symbol which suggests that we are going to do the scalar product operation. And that is to be divided by the product of the magnitudes of the two vectors. So for vector A, we use this symbol for the magnitude. Okay, the two slash symbols here suggest that we are going to consider only the magnitude of vector A, then multiply it by the magnitude of vector B. Right? So that is our mathematical formula in determining the angle theta, all right, which will be expressed in degrees. All right. So we first determine the scalar product of A and B. All right. So what we do is we simply multiply the x component of vector A to be multiplied by the x component of vector B, and then add to that the y component of vector A to be multiplied by the y component of vector B. Substituting, we get negative 2.00, that's for AX, times 2.00, which is BX. And then add to this, all right, AY is equal to 6.00 to be multiplied by the y component of vector B, which is negative 3.00. All right. So when you do your math, we will get as the scalar product of vector A and B, which is negative 22.0 to three significant figures. Next is to determine now, okay, the product of the magnitudes of vector A and vector B. All right. So when we say magnitude of vector A, the formula is to get the square root. All right. Get the square root of the square of its x component plus the square of its y component. All right. The x component, of course, is negative 2.00. There it is. Then that will be squared. Now for the y component, of course, you have positive 6.00. That will be squared. So after getting the square values of these two numbers, they will be added. All right. And then later, the sum of the squares, okay, is inside the radical sign, so we will still be getting the square root. All right. That's also true. All right. For the magnitude of the vector b. So the same formula, we also get the square root, all right, of the sum of the squares of its x component, which is positive 2.00, and the square of its y component, which is negative 3.00, right? So after getting the square of these two numbers, we add them, and then later we'll get their square root. Okay? So this is shown in the next step. All right. So the result of getting the sum of the two squares for the magnitude of vector A is written here as square root of 40.0, right? While for the sum of the squares of the magnitudes of vector B, all right, the x and the y components, the result is square root of 13.0. All right. Whose square root, of course, 6.32, that is the square root of 40.0 to be multiplied by the square root of 13.0. All right. And finally, we get this product of the magnitude, the two vectors A and B, which is 22.8. All right, so before we proceed to the calculation of the angle theta, let's first refer back to our question. We are asking or finding the angle between the two vectors. All right, the two vectors A and B, as you can see, each of them is expressed in terms of their x and y components. All right, the unit vector I, whose value, as a matter of fact, is equal to 1. All right, uh, and the unit vector j, similarly, its equivalent is also equal to 1. So we are able to say that vector A, the x component of vector A, is equal to negative 2.00 because that is what is represented by the unit vector I. It is directed towards the positive x-axis, while the unit vector j, all right, is also directed towards the positive y-axis. So similarly for vector b, its x component here is 2.00, while its y component is negative 3.00. Now, moving on to our calculation for the angle theta using the formula arc cosine of the ratio a dot b divided by the product of the magnitudes of the two vectors. Since we already obtained, okay, these two, the numerator and the denominator. So we just substitute, all right? Negative 22.0, that's the scalar product of the two vectors, divided by the product of their magnitude, which is 22.8. Using your scientific calculator, okay, we got this value for the angle theta equal to 165 degrees. So, to have a better picture of these two vectors and where this angle theta is, all right, we have the graphical sketch. The vector A is represented by the red arrow, all right. So, if you notice, uh, it is drawn such that its x component is 2 units, all right, towards the negative x-axis, while its y component is 6 units, all right, 1, 2, 3, 4, 5, 6. So that is how we were able to uh, come up with this drawing. While for vector b, following also its uh, notation, it is said that its x component is positive 2.00, all right, while its y component is negative 3. All right, so that is how we were able to figure out a the magnitude as well as the direction of vector b. And when we say angle theta, okay, it simply means the angle that separates these two vectors. All right? So that is the angle theta. In other words, if you're going to measure the angle, for example, from this vector arrow and you move counterclockwise, all right, until you reach, all right, vector A, that will in fact be equal to positive 165 degrees. So that's how we solve this question. Thank you very much for watching. Please follow me in my FB page and please don't forget to subscribe to my YouTube channel.